welcome to another video on nodal analysis. Before we proceed, I would like to remind you to hit the like button, hit the subscribe button, hit the notification bell, and then we can proceed to finding these node voltages that we're required to find in the circuit. So our reference node has been given to us, and all we just have to do now is to label our nodes. So let's call this node 1, this one should be node 2, and this will be node 3. So we proceed to writing the KCL equations at node 1, but we don't really need to stress ourselves. We'll go to the stress of writing the KCL equations at node 1 because of how node 1 is. We see, you can see that a 10 volt power source has been connected between node 1 and the reference node. For this reason, if you were to take a multimeter, a voltmeter, put the negative terminal here, put the positive terminal up here, you get a reading of 10 volts. So without further ado, we can say that V1 equals 10 volts. Easy, right? So we can proceed to node 2. Then at node 2, you write the KCL. We write on this branch, write on this branch, write on this branch. So at node 2. So at node 2, we have V2 minus V1 divided by 2. That's the current flowing through that branch. V2 minus V1 divided by 2. Then at we write the current flowing through this branch. That would be V2 minus 0 divided by 8 plus V2 minus 0 divided by 8. Then you come here and you write the current flowing through it. Since we cannot write it the way we've been writing these ones, so you just assign a current to this branch and call it I. So that would be plus I, since it is leaving the node. So everything equals 0 according to KCL. Then we come to node 3 and we write the equation. So let's call this equation 1. Then at node 3. So at node 3, we write for this branch, that would be V3 minus 0 divided by 6. We write for this branch, that would be V3 minus V1 divided by 4 plus V3 minus V1 divided by 4. Then minus I, which would be equals to 0. So we equate everything to 0 according to KCL. So from here we can say that I equals V3 over 6 plus V3 minus V1 over 4. Okay, so we call this our second equation. Once we substitute equation 2 into equation 1, then we get V2 minus V1 divided by 2 plus V2 over 8 plus V3 over 6 plus V3 minus V1 divided by 4. Let's call this our we equate everything to 0 and call this our third equation. Or let's call this our third equation after we simplify it. Okay, so to simplify it, we proceed to multiplying through by 24. So if we multiply through by 24, we have 12V2 minus 12V1 plus 3V2, okay, plus 4V3 plus 6V3 minus 6V1, which is equals to 0. We get okay, we get 15V2. Then we have the V3s, that will be plus 10 V3. Then recall that V1 is equals to 10, so we can just substitute this. We have 12 V1 and we have 6 V1 minus 6 V1, so that will give us equals 180, and we can call this our third equation. Then we can connect our voltmeter here again. So if we connect our voltmeter here with our negative terminal here and our positive terminal here, we get a reading of 5 volts, which means that node 2 is greater than node 3 by 5 volts. So that means that V2 minus V3 equals 5, and we call that our fourth equation. We can then proceed to solving equation 3 and equation 4. We can proceed to solving equation 3 and equation 4 simultaneously. And then V2 would be equals to 9.2 volts, and V3 would be equals to 4.2 volts. And then we would have arrived at our node voltages. So we know that the voltage at node 1 is 10 volts, voltage at node 2 is 9 volts, and node 3 would be 4.2 volts. Thank you for watching the video. See you in the next video. Bye.